Hi, my name is Yan Liu. Today I'm going to present the network intrusion detector project of my final project for Big Data in Practice course. The dataset used here is KDD Cup 99 datasets. Here is an outline of my presentation. Next, I'm going to start with a brief introduction to this project. As we all know that network security is a very important issue. So the task of this project is to build a predictive classifier to distinguish bad connections and normal connections. The training data I used is KDD 10% training data. There are almost 500,000 records. The test data I used is the corrected testing data, which has more than 300,000 records. You can find the link to these datasets here. The original dataset used a lot of attack tags, but for the project we only focus on these four major attack classes. So we can see that there are additional new attacks in the test data, which is to examine the predictive ability of the model. I found this table from this article. There are 41 features in the datasets, including 9 basic features, 13 content features, and 19 traffic features. Most of them are numeric features. Here is a list of goals I have set for my project. The first one is to make sure that the detector won't impair normal requests from user. And the second one is to try to distinguish different types of attacks and to try to detect new attacks in the test data. Next is the data preprocessing. From the article provided by the professor, we know that there are 3 critical problems of KDD Cup 99 datasets. First one is duplicate records. The second one is the class distribution of the dataset is highly skewed. The third one is no matter which method you use, it is very easy to get relatively high accuracy. So it is important to make a definition of the evaluation of the performance. I took 4 steps to prepare the data. First of all, I removed duplicate records. After this step, I got 145,000 records in training data and 77,000 records in test data. Then I changed the class labels of these datasets. For training data, I mapped 22 attacks to 4 major classes, plus 1 normal class. There are 5 classes. For test data, I mapped the 37 attacks to 8 classes, which are 4 classes and 4 new classes. They are the same, but I want to evaluate the ability to detect new attacks for the model. And plus 1 normal class, there are 9 classes. Then I resample the data. From the upper right chart, we can see that there are a lot of records for DOS and normal classes, but very few for probe, R2L, and U2R classes. So I downsampled DOS and normal classes record and oversampled probe, R2L, and U2R classes. I set the final datasets for training data to be 50% of the original one. So after this resampling, I got 72,000 records for training data. Then for better evaluate the training data, I split the training set to 5 parts. I took 4 for training and 1 for testing. I also found some other issues from the data during this process. The first one is some attacks only appear in training data, so they cannot be tested in the test data. The second one is the feature number 21, which indicates whether the connection is host login. only contains one level in training data, and this will introduce problem for some models such as random forest if treated as logical data type. And the third one is the feature number 3, which indicate the type of service of the connection has 65 levels, which exceeds the maximum number of levels for some methods. Also, random forest had this problem. So I had to change some of these features to numeric to get the result. And next is the summary of the methods I use and the results. I've tried 4 methods: KN, naive Bayes, decision tree, and random forest. First, I run this method with default settings on the training data. We can see that they all have really good results on the training dataset. There's only one thing that naive Bayes didn't give relatively good results. Then I run these methods on test data. So KN's result is still good, but the recall rate on R2L, U2R, and the precision rate for U2R are not very good. Then the naive Bayes on test data gives better results than the training data, but the recall rate for R2L and precision rate for U2R and probe are unacceptable. Decision tree's result on test data was worse than the training data, and the precision for U2R is very bad. For random forest, the overall result looks good, but overall rate for R2L is really low, and still the performance of U2R is not good. Here is the error analysis of these methods. One common problem is that all the methods worked poorly on minor classes, especially U2R and R2L. This might be because of the lack of samples for these classes. There are not enough information to make this classification for these classes. For KN method, the result shows that it overlooked new attacks, and also another problem is the categorical features were changed directly to numeric features in my experiment, and the distance calculated based on these features didn't reflect the true distance among these records. And the naive Bayes result shows a strong bias towards probe and U2L. And also, especially for the traffic features, there are a lot of dependencies of the features. So future feature selection need to be deployed for naive Bayes. And the decision tree has very obvious overfitting problem, and the random forest also overlooked new attacks. So after choosing random forest as my favorite model, I selected some features to improve the performance of the model. From this article I found online, I learned that there are features that are most relevant to certain attack class. So I tried to train the data model using these selected features for certain class. I was expecting that by this way, the predicted result for certain class is more precise comparing with using all the features. So what I did to improve the model is that I trained this model using reduced features in each class and merge them to baseline classification. So by doing this, I have DOS training result, probe training result, U2R training result and R2L training result. One example of how I merge the results is including the baseline result, I have 5 results for each record, and I pick the most frequent class for each record, and this is the result I have. The overall precision is still good, and but still the U2R and R2L results are not ideal. And my best is to only merge R2L result. This means that for each record, if the result based on selected R2L features shows that this record belongs to R2L attack, I use this result regardless of which result I got from the baseline classification. And I made a table to compare the recall rates for the 3 methods I used. The original means the baseline random forest result. Mix-all means mixing all the results of the baseline result and the select features result and pick the most frequent class. And mix R2L means only merge the R2L result to the baseline. And we can see that the mix-all result shows that the recall rate on R2L and U2R improved, and but the recall rate for DOS and probe declined. For the mixed R2L result, the overall recall rate on probe and R2L increased, and the recall rate for R2L, new DOS, new probe, and new U2R all increased. The only problem is that the U2R recall rate and overall recall rate for this class declined. This is a table of the precision rate comparison of the 3 methods. We can see that the price of increasing recall rate for the mix-all method is worse precision rate for probe R2L and U2R. But for only merging R2L method, almost all classes have improved precision except for R2L. So here I summarized the improvement of merging R2L result on the baseline result. We can see that for recall rate, DOS, probe, R2L all increased, only U2R decreased a little bit, and the normal decreased a little bit. And for the precision rate, probe, U2R, and the normal overall rate all increased. Only DOS decreased a little bit, and R2L decreased a little. And here is a comparison of the count of each class for the 2 models. We can still see obvious improvement of the new model. The last part is future work. So if I keep working on this project, I would have to get more background knowledge of network security and to explore more other methods I used or not used in this project. And I need to do feature engineering, such as feature selection based on information gain, or changing the categorical features to binary or other manipulation of other features in this dataset. Okay, that's all for my presentation. Thank you very much for watching.